Next up, we will be discussing driving operational excellence with remote technologies. Our speakers are Jason Canty, Remote Operations Superintendent with ExxonMobil, and Hopkins Peyton, Completions Engineer with America's ExxonMobil. Please help me welcome them to the stage.
All right, y'all ready to geek out a little bit? I think Kathy and Brian set us up pretty good this morning talking through what are we doing to improve completions, but also a lot of the remote operations centers, what are we getting after in terms of trying to improve that operations excellence within the Williston Basin, but also across the unconventional portfolio. So I'll let Jason kick it off.
Thank you, everyone. I'm Jason Canty. I'm the Remote Operations Superintendent for ExxonMobil, supporting our Comet team on our Houston campus. The Comet team supports all of our unconventional assets in North Dakota, Texas, New Mexico, and other basins across the lower 48. So how did we get here? Comet is a 24/7 remote operations center supporting these assets. So we looked back years ago and we had a gap between our communication, between our optimization, and just overall surveillance of our unconventional assets. As you know, here in the Bakken, you have hundreds of sites unmanned, spanning across hundreds of miles. So visibility after hours, when the workforce had already gone home, you had 16 hours a day where you had limited visibility. Of course, we would get critical alarms on site that we would respond to, but there really wasn't a lot of optimization going on after hours. You had very limited visibility. So we took a kind of a page out of the playbook from our downstream. Kind of look at it as a refinery. A refinery has a board operator that's 24/7. He can see that whole operation through technology with their SCADA control systems. He has full control of all of your automation and control valves, and he has direct line of communication to maintenance teams and the operations teams in the facilities. So we took that same model and applied it to our unconventional assets, and through a lot of growth and deployment of automation and digital tools and expanding on our SCADA applications, we've been able to provide that same kind of visibility and control and communication with those teams where historically we didn't have that. So we went around and we sourced the best operators that we could find. We went to all of our BUs and we found the best lead operators, some foremen that we had, and we brought them into the center. And you can see in the picture right there, this is one of my leads. He's operating a console right now for the Delaware Basin, managing their water takeaway, and he's managing 700,000 barrels a day. He has full control of the system with valve control and direct line communication as well. So our team support GHG, our personnel safety, just by the communication we have. The work that we do, we can minimize the impact and drive time of our personnel. One of the most dangerous things we do in a lot of the basins is driving. So the more remote functionality we have and controls that we can make that would have historically taken an operator, and depending on location, maybe an hour, 2 hours, after hours to go respond to, we can take action immediately and mitigate the downtime and also provide him rest and relaxation. He can stay home and handle his business, or if it's during the day, he can focus on the valuable work that he's doing out in the field and know that we've got eyes on assets and we've got it under control. Like I said, it's 24/7 operation, and through technology, we have full control. Our teams in the Permian Basin, they talk to the production teams, to our midstream teams, to our marketing teams, and our third-party takeaway team. So anytime there's a issue downstream that's going to cause us an issue, takeaway issue, any outages, planned, unplanned outages, are mitigated and managed through our center, through that direct line of communication with the field. So before we worked in silos in the unconventional assets, today everybody's one team, that one integration model, one team. So everybody's aware and apprised of any issues that are coming down the line, and we plan for them, and we act accordingly to mitigate any flaring events, and also while optimizing our production in the downturn. So today in the Bakken, we're kind of in the infancy stage. We've been working with the local teams here, the engineering and operations teams, and providing high-level surveillance and operational trending of their critical assets. Flare abatement was a big topic. So the Comet team has been working with them for this past year to really put eyes on assets where we had flaring events that might have gone unnoticed due to lack of visibility. Today, with implementing new technology and adding automation and meters to the field, we can see these sites, we can see the conditions, the line pressures, we know when we're flaring. My team provides actionable information to the team. So they reach out, hey, you got a flare going off, and we're gonna handle it. And just know that if something's going on, we're not gonna just let it go on. We wanna be a good steward of the environments and the basins that we work in. And today we take that very seriously. So future outlook for Bakken. So we're working right now, again, scoping study with that engineering team and the operations team locally to figure out, okay, obviously number one is gonna be the flare reduction. And the work we've already done today has yielded a greater than 30% reduction in daily flare volumes. And going into 25, we hope to decrease that number further. So first off will be auto choke deployment. And the auto chokes are really cool, and we're gonna expand on the learnings that we've had from the Permian Basin. It's been broadly deployed there, and it's given us full control of our wellheads. So there's no shortage of issues. You're gonna have third-party takeaway issues. It's gonna happen. We're gonna have flaring events, but before we didn't have control over it. You would rely on somebody to see it and have to respond to it where it was hours in between the events. Now we can take care of those events. So we've scoped out critical sites based off of the highest GOR wells. So when we have an incident, we want to prioritize the production volumes and cut back on the highest GOR wells. That's gonna take the most gas out of the system, lower line pressure, and get us below those flare thresholds. So the cool thing about the auto chokes is even when we have a downturn, we can prioritize that production, keep the gas out of the system while allowing your higher oil volume wells to market. So we can, even in the issues, we can still make the best of that scenario. Secondly, we will deploy the optical gas imaging cameras, OGI cameras, and we're using those again in the Delaware. Putting these out on location is going to give us first line of sight and visibility of any methane events that are going on, any leaks on site. So just another added layer of protection. And I think you can see that going forward, we're really serious about just being a good steward of the operating areas that we're in today and making sure that we're taking the steps needed to stay up with regulations as they increase. We don't want to be behind the 8 ball on that. We want to stay ahead of that and be proactive in our mitigation of that and in leveraging technology. And we're not going to stop there. We've already piloted many types of cameras and devices over the last couple of years and centering down on the ones that we use today, but we're already kind of looking to the future on how we can expand that technology and get better at what we do. So I'll turn it over to Mr. Peyton.
Awesome. Thanks, Jason. So before I jump too far into this and dive into some of the DNC stuff we're doing from a remote perspective, I really want to make sure I drive home the two key takeaways. What is the end goal, us as an operator, but really any other operator? What are we trying to get out of these remote operations centers? It's two things. It's efficiency and it's effectiveness. Efficiency translates to lower cost. Effectiveness translates to more recovery, more barrels out of the ground, which is not only good for us as a company, it's good for our partners, it's good for the state of North Dakota. And that's really what we're chasing. They touched on it several times today throughout the speakers. You know, right now, we know our recovery factors in an unconventional space are more often than not, you're only getting less than 10% of the oil in place. How do we make that step change in performance on the effectiveness side to gain that 0.5% or 1% that has a major impact on the economics, but also on some of the other production knock-on effects you get with increasing that recovery factor? So the Remote Operations Center, you're going to hear me use ROC and FSC a lot. Exxon is infatuated with acronyms. I don't know if it's an industry thing or just us, but we love our acronyms. So Remote Operations Center is what the ROC stands for, but think of the ROC being our drilling kind of branch, and then we broke off and created a subset of FRAC, which is called the Frac Support Center, or FSC. So think of ROC We're drilling through rock. That's the drilling piece. And really the idea around all of this is we're trying to drive consistency. You look at when you want to leverage the scale we have as a company, we have quite a few drilling rigs, as you can imagine, across all the major basins we're involved in. And how do we take some of that information or some of the learnings we have in the Permian or Bakken or anywhere and apply those across the board to really make that step change in performance across our entire drilling organization? That's really what the rock's all about. And so it was established in 2020. It's primarily focused around our directional drilling and geosteering. And I'll dig into some more of that here in a second. But we also expanded that into some well planning and fluids, some logistics, trying to move the needle really on all those different parameters you have towards trying to get a better well, a more efficient well, but also staying in that target zone and hitting your target, right? So the rock is currently supporting all of our U.S. land drilling rigs. I don't have an exact number. I know it's in the mid-20s across our portfolio within unconventionals. And that would include any future drilling we have in the Bakken. As Brian touched on this morning, we're going to be spudding some wells in a couple months. We're really excited about some of our HBU development and looking forward to seeing a big rig going again up here. I got up to Williston in 2020, and I haven't seen a drilling rig yet. And part of that was because we had gotten so far ahead of our skis as a company coming out of COVID. We had 4 times as many DUCs as any other operator. So we've had a lot of inventory to work through on the frac side, and we'll touch on some of that here in a second. But really looking forward to seeing drilling coming back to the basin, and I know everybody's really excited about that. The Frac Support Center, we started that just last year. So we saw all the efficiency gains, all of the knock-on effects and benefits we were getting from the rock side, and we said, we need to roll this into frac, because at the end of the day, we're putting a well in the ground, but frac's really how you're going to get that oil out. So we're trying to tap this tight oil. We need to find a way to optimize our fracs. All of our fracs are currently called remotely from the FSC. So, historically, as you can imagine, a lot of y'all have been out to a frac site. You've got your company men, your consultants right there on location, and they're calling the job sitting in the data van. Well, we've kind of revamped that and brought that in-house and created a Houston hub for not only our drilling experts, but our frac experts, and we're running everything remotely from there. And really at its core, we're after that stage effectiveness like I touched on, and the frac uniformity. We want to make sure we're putting uniform fracs out there and we're tapping as much of that reservoir as we can. So we rolled that out in the Bakken asset for the first time earlier this year, working through some of the DUCs we had, and we achieved the best ever frac performance we've ever seen. In terms of efficiency, we got off a pad averaging damn near 21 pump hours a day, which anybody that knows about the frac business, 21 pump hours across a 9-well pad is pretty impressive. And so that's kind of the idea around the rock and the FSC and kind of the evolution of how we got to where we are. So let's drill a little deeper into the drilling side first. So when you talk about the rock, take yourself back to COVID. We had 60 drilling rigs running across our unconventional portfolio. And then COVID happens, and we go from 60 drilling rigs down to 7. So that kind of gave us a unique time to reevaluate how do we drill our wells, but also how do we roll through the ups and downs with the market and how it cycles. And so what we did was, first of all, we're down to 7 rigs. Historically, you're going to have 2 directional drillers on any given drilling rig at a time. They're on the rig, they're drilling from the rig. And we kind of decided, hey, let's retain the best DDs we have. We were seeing varying levels of drilling performance on a per rig basis within the same rock. So why are we seeing those varying levels of performance? You have directional drillers that have varying levels of experience. Let's bring the best guys we've got, bring them in-house, and give them the keys to more drilling rigs. So instead of directionally drilling for 1 rig, I've now got our best directional drillers, and they have the keys to 6 rigs. They're directionally drilling 6 rigs at the same time from a remote operations center. And what that delivers is better consistency, but it also delivers better wells, because we all know as a market, when we see these cycles come through, and everybody saw it here, when it took off after COVID, and all of a sudden there's this huge demand on the workforce, you've got guys that probably aren't qualified to be directionally drilling, but you've got to give them that opportunity because there's no one else to fill that void. And so what we decided as a company is, instead of having that variable drilling performance based on who happens to be in the seat on the drilling rig, is let's bring that in-house and get a higher consistency and better delivery across the board. So that's one piece of it. Most of our we've got directional drillers in the rock, we've got geosteers, some well planning engineers, and fluids monitoring. But most of our team members have 10 plus years within the industry, most of that in the role that they're currently serving. Another really knock-on effect we saw that was pretty interesting with all this was these guys have been working for ExxonMobil for a long time. So even if they are, a lot of them are contractors, they have a deep understanding of what our standards are and our operations integrity management system. And so it's really cool to see the level of dialogue that goes on when we're planning these wells and we say, hey, maybe we should drill it in this perspective. And they're like, well, that might not jive with some of our OIM systems, or that might not jive with some of the SOPs and how we want to drill these wells. So there's just a very high level of understanding of how we want to effectively and prudently drill these wells. And then another thing we learned, obviously there's going to be growing pains when you spool up one of these units, is communication is crucial. You can be the best directional driller in the world, but if you don't know how to communicate with the guys on site and the drilling rig that's actually doing the work out in the field, you're not going to get anywhere. So we figured out really quickly, not only do you have to be a really good directional driller or geosteer, you've got to have that communication ability to be able to reach out to the rig, talk to those guys, and be able to talk back and forth and bounce ideas off each other. One of the really big differentiators, I would say, like I said, we're after that efficiency and effectiveness. We want to drill these wells as quickly as possible, but we want it to be effective. We want it to be in our target formation. I'm a completions guy by background, and there's nothing worse than trying to frack a well that's, kind of on the bounds of your formation and you can't get breakdown because you're not in the rock you wanted to be in. So trying to kind of having all those guys in-house and having that dialogue, kind of being able to bounce ideas off each other and having all of that run in one little area, they're all able to talk through some of the challenges they have, and you do see a really big increase in performance. So what we're trying to mitigate is major disruptions. Worst disruption you can have on a drilling rig, right, is maybe twist-offs, sidetracks, stuff like that. We're really trying to mitigate the major disruptions that kind of impact your assembly line. And all of us, we know this. The unconventional plays, this is really an assembly line. We want it to be a well factory. We want to be churning out wells effectively, efficiently, and we want to be doing it without defects. So if you have a washout, sidetrack, anything like that, it causes a huge disruption, not only to scheduling, but it's just a domino effect on getting wells to sales, getting that production online, and things like that. So that's some of the things we wanted to find a way to mitigate. And some of the ways we're doing that is not only bringing, like I said, retaining the top talent, but we are also leveraging data. Data is a big piece to these remote operations centers. So what we're doing is we're leveraging machine learning models that are internal to our company. And those machine learning models, we actually have one directly dedicated to preventing washouts. And year to date, we've been able to prevent about 85% of what we believe would have resulted in washouts and a lot of NPT, a lot of hassle on the drilling side, simply by giving us an alarm ahead of time, and we can kind of prevent that before we get too far into it. Going down further, the ability to a la carte directional services, if you think about the way things have historically been done on the drilling side, you've got a directional drilling company, they provide MWD tools, it's kind of a one-stop shop. But maybe they don't have the best motors in the world. Maybe they have good drillers, but their motors aren't the best. And so what we've been able to do by bringing this in-house, we can really mix and match to create the best bottom hole assembly we can, so that maybe if we like motors over here, but we like these guys, or we like their survey equipment, stuff like that, MWD, we can put that together to have an optimal bottom hole assembly for drilling efficiency and effectiveness. And then going down into our auto driller, if you think about how far drilling's come, we have an auto drilling program, and like I said, the directional drillers, you probably ask, how can they drill across 6 wells at the same time? Well, more often than not, you're not going to be steering 6 wells at the same time. For those that aren't aware, there's kind of 2 modes when you're in the drilling process. If you're happy with your trajectory and you know where you're headed, you're rotating out. So that's when you see the drill pipe spinning from surface all the way down. You're providing torque through that top drive, and that's how you make all your rate of penetration. You're making a lot of footage. You're getting it. And when you're actually steering, where the rubber meets the road in terms of steering the well and getting it back on track, that's what we call sliding. So you're not actually rotating the pipe from surface at all. You're pumping down through your mud motor, and the only thing that's spinning is that drill bit. And so then they're able to basically take advantage of where the tool face is, and that's what a directional driller does. And so where we're at this point, our guys are watching everything. When we're rotating out, we have what we've built through different basins is what we call recipes. It's an iterative process. And so when I mentioned leveraging scale, we've drilled thousands, hundreds, and if not thousands of wells in most of the major basins we're active in. And so we're always making those tweaks to get that recipe optimized. But when we go to drill in a new area, like we haven't drilled up here since 2020, right? Well, we were doing great back in 2020. So we're gonna pick up that recipe, we're gonna wipe the dust off of it, and then we're gonna start making tweaks to continually get better. So it's always that iterative process. But I kind of liken it to, sure, everybody's got, their favorite recipe from grandma and grandpa, but you like to add a little bit extra or tweak it a little bit to your likings, and that's exactly what we're doing here. And so this automated bit guidance, you've got your bit guidance, and you've got your auto driller. Think of your automated bit guidance. It's a program that says, hey, I'm currently right here, I've got my bit, I know where I want to be within my drilling plan. Where am I going to be when I get this next standout? Where am I going to be 90 to 100 feet? And it can project where it thinks it's going to end up at. It'll feed that data over to the auto driller, and it automatically makes adjustments to where a lot of times the directional driller is not even touching anything. It's steering itself. And so this is only going to go further and further as we continue to leverage that data and really drill down into these recipes and this automation. Really, the sky's the limit when it comes to rolling the AI into this and things like that. So holistically, all the sliding is being done from our Houston hub across our unconventional play. And we're really seeing a big boon there in terms of continually setting records internal to our company, but also setting industry records in terms of not only efficiency, not having to make trips out, making those effective, one run, drilling out all the way to TD, but making those footage records on a lateral footage per day basis. So that's kind of where we're at with the drilling rock, and like I said, it's an iterative process, so we're continually trying to improve how we drill these wells. Kind of moving into completions, you spent all this money drilling a well. You spent over a couple $1 million putting a well in the ground up here at a minimum. Now what do? Because at the end of the day, drilling, yes, we want to get efficient, but you've put the pipe in the ground. I can't just go down and perforate and produce oil. You're not going to see anything. This is tight oil. We have all this oil in place, a bunch of porosity. We have no permeability. We have no way to create those super highways for your oil and gas to flow into the wellbore. And so that's where frac comes into play. We really want to be efficient and effective on our fracs. You can see, really, well, I guess I'll break it down to begin with. The way we roll through on the FSC is, once again, leveraging data. We get data from the drilling side. That feeds into a pre-pad. Our guys in the FSC, we've got stage optimization engineers, frag bosses, and then some technical advisors. We've got some PhDs that are just complete experts in geomechanics. And what they're targeting is they want to look into a pre-frac kind of risk analysis, and they want to say, what does the data on the drilling side tell me about how I think this rock's going to frac? It's not a uniform, same exact rock all the way across a 2-mile lateral. You're going to see varying levels of rock characteristics as you work your way back. And so if I know what I'm dealing with ahead of the frac and they can identify some of the zones where we're going to have issues, then I can tweak my design. If you think about it from going back to the assembly line, look at a Ford truck. The chassis is the same, the motor's the same, everything's the same, but we don't want it to be a cookie cutter design. We want to be able to roll out a different trim package every now and then. Maybe I need a King Ranch over here. Maybe I need a Platinum over here. It's just trying to tie back. At a base level, the design is going to largely be the same in a certain basin, but how can you make those specific tweaks on a per stage basis to drive frac uniformity and tap more rock? And so some of the things that they do ahead of time is they identify those challenging stages, but then they'll feed that to me, and as a completions engineer, I put together my procedure. We have a pretty good game plan. You get around to the execution piece, things never go as planned. And so on the fly, we want to be really agile in terms of making decisions on the fly and adjusting how we frac these wells to try to get as much oil as we can, right? So that's kind of where the FSC brings their value, is not only ahead of time analyzing the data, but on the fly, they're watching every single stage. You can imagine, as a completions engineer in the old world, sure, I'd get stage reports, but there's no way I'm going to be able to review every single one of them. We have 24/7 monitoring of every single stage that gets pumped across our portfolio. And so you get those shared learnings, you get signatures you pick up on, and you start to trial minor little tweaks to your design where now all of a sudden you're getting more effective fracs, but you're also able to get the fracs put away more efficiently. So we're also looking into zonal isolation is a big thing. You want that good plug isolation, but we also we're starting to look more into feeding back to the drilling side. It's kind of this endless loop. What we're seeing on the frac side, if we see that we have bad cement on the backside of some of our lateral, maybe we have cement channeling to where between each individual perf, my fracs are talking back and forth to each other. And so you're not actually effectively fracking that. You're talking to the previous stage and you're just throwing money away. You've already effectively stimulated that area in the lateral. And so as we're going through this execution, they're constantly gathering data on the diagnostics piece too, to feed back into that iterative process I talked about, to continually chase the holy grail of a perfect well, which is never gonna happen. But we're always trying to get better and better, right? So going over to the diagrams here, like I said, we're looking into a lot of the data, but what are the results? So we rolled this out in 2023. This is an average daily pump hours per frac crew. At any given time, we're usually running 6 to 8 frac crews across our portfolio. And you might say 17 hours, that doesn't sound very good on a 24-hour basis. Keep in mind, it used to be even lower as an industry. It used to even be, when the Bakken kicked off, they used to roll in and frack a well in one day, and it was a day shift thing. It wasn't even 24-hour operations. So it's come a long way in the last 15 years, but 17 hours in 2023, we start rolling out this FSC. You find different ways to become more efficient, and oh, by the way, the knock-on effects, your guys on site, now that they're not having to be in the data van and call the job, they're walking around and making sure things are being done operationally, logistics, everything's coming to be lined up. You're kind of staying ahead of the ball, and you see these knock-on effects with efficiency, but your guys are also able to keep a closer eye on safe operations and making sure things stay safe out there for everybody. So we've gone from 17 hours, year to date in 2024, we're at 19. That still doesn't sound that great, right? Well, we've got crews that are consistently hitting in the last quarter 21 hours, 22 hours. We've got some crews hitting 23 to 24 hours a day. And like I said, we just hit almost 21 hours across a 9-well pad for a whole solid, month of fracking. So pretty good. Down to the bottom, going back towards that effectiveness piece, right? We all know in the industry we have these suboptimal fracs, which are kind of on the right side of your graph. That's not ideal. You're going to leave behind oil. We want a proportional amount of fluid and sand to go out of every single hole that we shoot in our lateral. Every perforation we put down there, we're designing around an optimal amount of fluid and sand, and that's exactly what we're going for here. So you're kind of trying to see that paradigm shift of, with a cookie cutter frac, you're probably getting suboptimal fracs pretty often. We're trying to start tweaking those designs on the fly to where eventually we can start transitioning more to uniform fracs across a lateral, and that's going to turn into higher oil recovery. So on to the next slide. This is really just a snapshot of what one of our FSC pods looks like. We currently have 4 pods. That's obviously going to be getting expanded with the Pioneer acquisition, but each frac pod has the ability to watch 2 frac crews. So with the rock, like I mentioned, 6 drilling rigs per pod. These guys, the frac bosses, they're watching 2 frac crews at the time. And really, I just wanted to show a snapshot of all the data we're gathering. So we're running different things such as Corva, Cold Bore, all of these data analytics tools and aggregators, and we're trying to get down to finding those little tidbits of information that are going to move the needle in terms of well performance in the future for us. And then finally moving on to key takeaways. Jason, you want to touch on the comment?
Yeah, just for my team, the Remote Operations Center for unconventional, today we're just going to push through. We're going to continue to leverage our relationships and technology across the basins that we operate in and just continue to get better and minimize flaring, optimize production. And we're on a journey right now, and it's been a ride, and we're looking forward to coming to the area and spending more time and developing those relationships.
Awesome. And yeah, that's what we're super motivated about at ExxonMobil is continually getting better, right? Working the Williston Basin, if anybody's familiar with that Bear Den area, you look back on these wells that were brought on 2010, 15 years ago, everybody was going crazy that we had a well that came on at 800 to 1,000 barrels a day. In that same area, in the last couple of years, with some of the things we're rolling out here, we're bringing on wells that can do 3,000, 4,000, 5,000, 6,000 barrels of oil a day. and the frac that I said, the first one we rolled out with the FSC this year, that happens to be the best well brought on in the state this year. It did about 93,000 barrels of oil in the first 30 days. So pretty solid performance. We think we're headed in the right direction, and that's what it's all about. We want to leverage the scale and expertise of our corporation across our portfolio to maximize that recovery. And that drilling and completions performance on a well-by-well basis, getting that optimization in there is going to drive all the value in the world across the life of that well. It really comes down to that initial capital investment, and then once it's on production, you gotta keep that base up like Brian was talking about this morning. So we want to incorporate those technologies and immediately build those learnings in to disseminate that information across the board as quickly as we possibly can. And then finally, I just wanted to thank NDPC for allowing us to come out. Really appreciate everything we get to do up here, and working in the Williston Basin is truly a pleasure. So I want to thank everybody that's here in the room today.
Thank you.